So lesson 8 and lesson 9, formulas that you already know about geometry. Okay? We're going to start, we're going to list some, and then we're going to talk about them and do some problems. One of our first formulas in geometry that are dealing with shapes is the perimeter. Can somebody tell me what is perimeter? The outline of a shape. Okay, what else about you say?
It's like all the outside lines added up.
Adding up all of the outside lines. Okay, I completely agree with both of those. In the real world, outside of here, when would you ever see perimeter?
Architecture.
Okay, specific. Okay, specific.
Construction.
Be specific. How? What in the room is perimeter? Okay, the walls. What about the floors?
I feel like doing carpet. You know what I'm saying? That's like
How long the floor is.
How long the floor is. Okay, so if you're talking about construction in a room, I see this baseboard, right? To know, what do I need to know how much baseboard I need? The perimeter. I need the lengths and the widths, right? Some people put crown molding up at their house. That's a perimeter. Some people put fences around their backyard. They're having a perimeter, correct? If you ever walk your dog, you walk around the perimeter to teach them where they're supposed to go. That's where you go. So let's have a formula for perimeter. Now that you know what it is, it's all the sides added together. Do you know that automatically? All the sides added together. What's a good way to say that in the formula?
So length times width plus width times.
Okay. So you got a width and a width, a length and a length. So how do we put those together? What's
2L plus 2W.
2L plus 2W? Does it matter that I wrote 2W plus 2L? No. Okay, what if I had a square? What's special about a square?
You can do one length and then add it on top.
So one length because all the sides are the same, correct? So I'm just going to put above here, this is a rectangle. What would we do if it was a square? Multiply the side length times 4. I'm just going to put an S for side length because all the side lengths are the same. This side plus this side plus this side plus this side. Another one we will use is area. What does area mean?
Length times width.
Length times, if you gave me a formula, what does it mean? What do you see in real life?
Like how much stuff you can put in one thing.
They corrected you. It's volume. That's volume.
It's like how
the
many?
like the square. Like you know like that.
Square footage is area. Carpet. Do you need to know the area to know the carpet? Do you need to know the area to paint a wall? Yes. Okay. If you're going to lay sod outside, that's the grass. That's area. All right. We can fence in and we can sod. Those are perimeter and area. What about if it's a square?
You should multiply the side times 2. Wait, no. No, by itself. Sorry. It'd be like 4 times
You
4.
square.
Side times the side. They're the same, right? So what's another way to say that?
Side square.
Side squared. Which is just side times side. Now, another one we probably need to talk about that I haven't written up here is a triangle. Okay? We really aren't going to talk about the perimeter of a triangle because it's just a side plus a side plus a side, and they don't have to be the same. Okay? So what about the area of a triangle? Length times width divided by 2. What else?
I thought it was base times height.
Oh,
1/2 base times height.
Yeah,
Okay.
divided by 2.
okay. So I'm hearing some different things with a length and a width, and a base and a height. What's the difference?
Base is like the point of the triangle down to the bottom.
Okay.
It's what makes a 90-degree angle.
Okay. I like that. I'm gonna go with that. Can I write this or this? Are they the same? They're different words. But are they the same thing?
Yeah.
I'm going to go back to over here, this rectangle. Most people are going to say base times height. They're not going to say width times width much. Okay? Let's go for a wall. This wall right here that we're on. So I want to find the area of this. Could I find the length at the bottom? And the width up? Could we also call that the base and the height? Generally, you're thinking of something standing up that has a height, okay? But we're still talking about two-dimensional things. They're flat, okay? Somebody brought up a triangle and the right angle marks, okay? Where's the base and the height? Doesn't matter which way it's leaning, which way it's up. No. Your base and your height are where the right angle mark is. The right angle mark will always point to the base and the height. Okay? What if it's an acute triangle?
You put the line down
You put the line down the
the middle.
middle. So they will always be with these little dash lines and a right angle mark. Guess where your base and your height is? The right angle mark is always pointing to it. What about an obtuse triangle while I'm drawing triangles? What do? They draw a little dash line up here, put a right angle mark. Where's your base and your height? Height and base. Here's a hint, here's a secret. You will never, ever use a slanted side. If it's slanted at all, you will not use it to find the area of a triangle. We're not using it. 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 They're all slanted. Okay? We're writing one that's straight and going at a right angle to it. Okay? Are we okay with that? Not telling you anything you don't already, I think, know. Something else that we talk about with triangles. More specifically, right triangles. Do you remember a wonderful thing called the Pythagorean theorem? And I think I spelled that correctly. The Pythagorean theorem, only used with right triangles. Okay? I make assumptions that when you were taught the Pythagorean theorem, you know something about right triangles. Okay? Did anybody tell you about right triangles? What is this side called and that side called? Okay. Everybody says A and B? Did you know that they actually have names other than A and B? Those are variables.
The big slant was the hypotenuse.
Okay, so I didn't ask for that one, but yes, the slanted one is called the hypotenuse. Yes. It's not called C. It's a spot for C. Okay? Did you ever know that there are legs of a right triangle? You do now. I found that out today that when I teach the Pythagorean theorem, which I didn't have you in middle school, it's a leg squared plus a leg squared equals the hypotenuse squared. Okay? Because if you're looking in your book, Joanne, are you at 8-1? The Pythagorean theorem? If you are at this, you're going to write it sometime, but let's read it. Go ahead, Joanne.
The sum of the square of lengths of the legs A and B
b squared equals c squared. The sum of the legs squared. So you have to know that this is a leg and it's squared. Okay? And this leg is squared will equal the hypotenuse squared. So yes, I know we all need to know a squared plus b squared equals c squared. Okay? But you need to know that it's the legs, and only right triangles have legs, just so you know. So if they're talking about the leg of the triangle, that should be an indicator that, hey, that's a right triangle. Okay? What else is something you know? So we talk about the legs, or where the right angle marks are really, we can say they're your base and your height. What else do we know about the hypotenuse? What's special about it? It has to be the longest side. What else? It's always the slanted one. Always. What else? One more thing. What else do you know this? It's always across from the right angle. And it's always by itself. It's always by itself on the side with the equal sign. Okay? So the longest side has to be by itself. Okay? Are we good? Can you prove to me? Can you show me that you know how to use the Pythagorean theorem? Let me think of some numbers. Here we go. 12 and 13. Can you find x? Alright, this one. Alright, I don't want to know an answer. Can you tell me what formula you wrote down, Paxton?
I did like c squared minus b squared equals a squared.
Okay, he rearranged it. Did anybody else do that? You did it that way? John, what did you do?
I did a squared plus b squared equals c squared.
Are those the same? What did Paxton do that was different? This kind of defeats my whole purpose of C's always by itself. What did he do?
He solved for A.
He solved for A. He solved for a side length. Is that okay to do? Yes, it is. Okay? My person does not do that. Okay? Dr. Harms loves it. Physics. Okay? Now, she's not teaching physics, so when I talk about it, they don't know what I'm talking about. She rearranges every time before she solves. I plug in numbers and then I solve it. Okay? So if I were just plugging in numbers, Paxton, what numbers are you plugging in?
169.
What's the next line that you're doing? I'm going slow.
Just say 13 squared minus 12 squared is
Okay. I like that. Okay. If I'm doing this, I'm saying x squared plus 12 squared equals 13 squared. Okay. Does it matter? No. I'm going to solve them simultaneously. So next, what do we do?
the square.
No, you break
you have to square. Penrod says square it first. So 169 minus 144 equals what? A squared. Don't fall into my trap that I do every time. Don't just say it equals 25, because then where'd your variable go? You're solving from nothing. Okay? So then my next step would be 25 equals a squared. Okay? How do we solve for a? Find the square root. I hope this never happens to you. That you get to 25, that you say 169 minus 144 equals 25, my answer is 25. Okay? I hope that never happens to you. Why logically does that not make sense? That would be the longest, and it can't be longer than 13. Right? 13 has to be the longest side, so when you take the square root of 25, what did you get? Okay? Now I'm going to pause right here and ask you an algebra question. Actually, I'm not, it's just a math question. What's the square root of 9? Automatically. 3 times 3 equals 9. It's the only thing times itself that equals 9. When you take the square root. Okay. There's no other number times itself that will equal 9. Yeah, there is. Thank you. What is it, Sadie? Negative 3 times negative 3 will equal 9. In algebra, you hopefully learn when you take the square root of something, it can be positive or negative. I hope that you did that. So the square root of 25 is 5 or negative 5. Right? In geometry, we're still going to think that way, but we have to go back and put it in context. What are we talking about? Side length of a triangle. Can a side length of a triangle be negative? No, it can't. So I agree, our answer is 5. Okay? There will be times when the negative will work. Okay? So don't just say, oh, it's 5. It can never be negative 5. Sometimes it will be. Okay? Do I need to solve this my way? X squared plus 144 equals 169. And then I would subtract 144 here. X squared equals 25. Square root x equals 5. Okay? That's me. Either way, you get the same answer. One way is not better or worse than the other. Okay? Do it how you want to do it. Are we good? Pythagorean theorem. If I give you 2 legs, can you solve for the hypotenuse? I hope so. Alright. Next, we're going to talk about the distance formula. Okay? And I'm going to go back really quick to lesson 2. I think it was lesson 2. It's in one of the postulates that's talking about if you're on a line segment from here to here, from A to B. If it's on that straight line, what's the distance? It's the absolute value of A minus B. You've had that in a postulate. We talked about that probably now weeks ago. Okay? That's how you find the distance if they're across on a straight line. But what happens if they're not? What happens now if they're different coordinates? Okay? They're on a coordinate plane and they're moving different places. Let's go negative. I've yet to pick one that came out nice, just so you know. -8, -3 to, let's say, 4, 7. Okay? So now, this, all of a sudden, we're not on a straight oak. That's really not straight. Okay? We want to find the distances going diagonal across our coordinate plane. Okay? The distance formula, D equals. I'll go ahead and give it to you. I figure a lot of people have seen it, but I'm going to give it to you anyway. It is the square root of x1 minus x2 squared plus y1 minus y2 squared. And the square root of all of that. That's a formula. I'm going to tell you something that's a secret that nobody else, well, okay, plenty of people know. But the distance formula is not new. The distance formula is something you already know, that you've already seen today. If I take this point and go across and go down, what did I just make? More specifically, a right triangle. Where the distance from here to here is what? It's the x's, negative 8 to 4, right? The difference of the x's squared. What about this distance here? Oh, is that the difference of the y's? It's really this. Squared. Does that look familiar to you? The distance here squared plus the distance here squared can equal the distance that I'm looking for squared. Could we really just square both sides and have a d squared equals the difference of the x's squared, the difference of the y's squared? What does that look like? From negative 8 to 4, I believe is 12 units, yes? From negative 3 to 7, I think it's 10 units. How can I find D? No, don't put anything on paper. Tell me, how? That's the Pythagorean theorem, right? If I square both sides, what do I get? D squared equals the distance of my x's squared, and then the distance of the y squared. All it is the Pythagorean theorem. That's all it is ever. So if you have 2 points that are plotted somewhere on a graph, and you're like, I don't remember the distance formula. Oh my gosh, I don't remember this. Every time. Okay, so we're going to check to see, does it work? Okay, we've already kind of figured, because we can do this distance from A to B. From negative 8 to 4, we know it has to be 12. From negative 3 to 7, it has to be 10. Are we going to see those same numbers again? Well, let's see. D equals the square root of, does everybody see x and a y? And an x and a y? If we're plugging this into a formula, I know you're already asking this question. Well, which one is x1 and which one is x2? Which one is x1 and which one is x2? Which one's y1 and which one's y2? Oh my goodness. So taking the difference of them and I'm squaring it. Do you know that 5 minus 3 squared, so 5 minus 3 is 2 squared, 4. 3 minus 5, what's 3 minus 5? Negative 2 squared is 4. It does not matter the order you subtract it when we're squaring it, because you'll get the same number. Okay, so my x, I don't know, doesn't matter. What do you want to do? What if I did negative 8 minus 4 squared, and on the other one, I even switched the order, and I did 7 minus negative 3 squared. Could I do that? As long as my x is with my x, my y is with my y, I can. Now, how do you subtract with the positives and negatives? Negative 8 minus 4 is, add the opposite, what do you get? Negative 12 squared. Now, 7 minus negative 3, what do you do? Add the opposite, and you get what? So, So negative 12 squared is, what's negative 12 times negative 12? 144. 10 squared is 100. What do we get when we add them together? What's the square root of 144 plus 100? Yay! Can we be done? Kind of, not really. Okay? Sometimes you just follow directions. What does it say to do? First thing I'm going to check, does it have a perfect square? Do you know the square root of 244? It doesn't. I'm just going to tell you that. I've yet to make one up today that does. That's the first thing I'm going to check. Directions. If it says round the distance to the nearest 10 or the nearest 100, you're going to put it in your calculator and you're going to be done. Okay? Sometimes it will tell you to leave it in simplified radical form. Okay? Do you know what that is?
It's just like the way that.
We're going to leave it that way. Yes.
Oh,
Because I don't know if you know or not.
oh, I thought maybe it would be like you try to like you have the square root, you try to go as deep as you can, like you basically.
So I'm checking to see does 4 go into it?
Yeah.
Or 9? Or 16? Or 25?
So
Why am I picking those numbers? Perfect square. So yes, I could factor it all the way to prime factorization and see if I can put stuff together. With this, I'm 100% sure that 4 goes into it. Test for divisibility, when you learn those whenever ago, amazing. I don't even have to think to know 4 goes into that. Why?
This is right there.
Nope. Because it ends in a 4? It ends in a 44. And I know 4 will go into 44, so I don't care what number that's at. So I know 4 will go into it. I might even check 16, because I have a calculator and I can do that really quick. Okay? It's not my lesson for today. The first one I've had that I can simplify. The other ones I couldn't simplify earlier today. So I've made up different numbers to see, could I get one that works better? Okay? But whatever the instructions say, I don't think they will ever ask you to do simplified radical until we talk about it in class. Okay? And then it'll be a big deal. So distance formula. Are we okay? D equals square root of x minus x squared plus y minus y squared. Yes? Alright. Actually, I think that's it. That's the last formula that I have. Both my classes asked me about another one that I gave to them that you learned last year. So I'm just going to go ahead and give it to you. Somebody said, there's a formula that has like, something about a 4 in it. You remember a formula with a 4 in it? I don't know if it's really long. I don't think it's really long. But then I found out that they don't, whoever taught you this last year, did not sing you the song. And it's an amazing song. Okay? The quadratic formula, I will never ever test you over in this class. We will never talk about it. We will not test you. Does everybody know what a quadratic is, first off?
It's a 4-second question.
No. No. Well, the formula has a 4 in it, but that has nothing to do with what is a quadratic. You have linear equations. Does everybody know what a linear equation is?
Oh, it deals with
Give me
graphing.
everything goes with graphing.
Okay.
So why? Okay, linear equations sound like what? The line that's y equals mx plus b. You know that's a linear equation. It will always make a line. Quadratics will always have a squared in it. Just one thing squared. X squared. Or y squared, but not both. Okay? So, if you have a formula, I'm just going to go ahead and write, if you have an equation, ax squared plus bx plus c equals 0. It's a standard form of a quadratic. Okay? No, that's an equation. What's the difference between an equation and a formula? You don't know. Well, a formula is how to solve for something. Okay, so are you ready? Because I can't write it unless I sing the song. So in your head, think, pop goes the weasel. Okay? It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the song. Okay? When will I ever need to know this? If they ask you to factor something. You're like, I can't factor this. Look at all these numbers. They're too big. I can't do it. I'm totally bumfuzzled by it. You put it in quadratic formula. Okay? Eventually, I'm going to test you. Here's a quadratic. Solve it 4 different ways. Factor it. Use the equation. Use the formula. And there's some others. Okay? You will know 4 different ways, possibly, how to solve a quadratic formula. Quadratic equation, this is one of them. Okay? So if you need to factor something, so here you got your A, B, and C. Well, they're here. No, this is the formula. X equals. X equals. That's your formula. Because you'll solve for what X is. And it's a parabola. And it gives you where it goes through the x-axis. Does everybody know that that's what these are quadratics? It's a parabola. And this gives you x equals, and there'll be 2 answers because that's exactly where it goes through the x-axis. Okay, it's when y equals 0. Okay, that's the picture of what it looks like. Oh my goodness, sorry, I went on a little rant. So we do have a little bit of homework. Lesson 8 and lesson 9 practices. It's just the A, B, C, D letters in lesson 8 and lesson 9. Also, I need you to go ahead and write theorem 8-1. The only one we talked about is the Pythagorean theorem. Okay? Any questions? No? All right. I apologize. We are done.